Alright, we have Miss Chen's tables and chairs problem. So the text or the question gave us if there was one table, 5 kids could sit around. If there was 2 tables, 8 kids could sit around. So already I can put that into my T-chart or my table values, and I can say 1 and 5, 2 tables and 8 people. And I wanted to sketch out the third one just to make sure that the pattern was increasing by 3. So I drew my 3 tables and checked, and 11 people can fit around 3 tables. So this, I already know my pattern's linear. I know it's increasing by 3, and now what I need to do with it. So in my table, I've labeled it with more than just N and V or X and Y, and I've said that this column is my tables, which I'm going to use the letter N, and this side of the table or column is chairs, and we're going to use the letter C. So the first part of the question says, how many students could sit around 56 tables joined this way? So I know that they're saying N is 56. I'm never going to go through all of these individually. I need to figure out an expression so that I can get to 56. So if it increases by 3, that becomes my coefficient. So 3 is my multiplier. So 1 times 3 is 3. 2 times 3 is 6. 2 times 3, sorry. So 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. How does 3 become 5? Add 2. How does 6 become 8? Add 2. And how does 9 become 11? Add 2. So that has been it is constant, so that will become my constant. And plus n. So I have, plus 3 is my expression. Plus 2, not 3. Plus 2. And because it's a word problem, we can make it an equation saying that C equals 3n plus 2. So again, the question wants to know when there's 56 tables, how many students can sit there? So I'm going to go 3 times 56 plus 2, which is 168 plus 2, so 170. So 170 students or chairs. Okay. The second part, how many tables would be needed to fit 81 chairs? Would there be any chairs left over? So we had chairs is 3n plus 2. So if we had 81 chairs, which means my C is 81, we're going to have 81 equals 3n plus 2. And like we did with circles and like we've been doing throughout this unit, I need to get rid of the 2 on this side, so subtract it here and subtract it here. So 81 subtract 2. 81 subtract 2 is 79 equals 3n. 3 and n are being multiplied, so we divide both sides by 3. 79 divided by 3 is 26.33n. Can you ever order or choose or set up 26.33 chairs? No. So you need to decide, is it going to be 26 or 27 chairs? Or sorry, students that are able to sit, or tables. Back up. N is tables. So if we have 81 chairs, we're going to need 26 or 27 tables. So I'm going to try n at 26, and I'm going to try n at 27. So n at 26 is 3 times 26 plus 2. 3 times 26 is 78, plus the 2 is 80. You can show that step, I'm just doing it quickly here. So obviously there's a student missing or a chair missing, right? We can't just tell one kid to stand, too bad we don't have enough chairs. So we're going to have to use the 27, and I'll just make sure and show my check. 3 times 27 is 81, plus 2 is 83. So we would need 27 tables and that would have 2 extra chairs. Since this is 83 and we only wanted 81. The last part of this one, you need to visualize it. So if you had a lunchroom, and because obviously we couldn't sit our whole school in one long line, but what if we had several lines? How many of these rows would we need? So she wants each class to sit in one long row in the lunchroom. How many tables are needed in each row if every class has 26 to 30 students? So if I need at max 30 chairs in a row, how many tables, how many tables, which is our n, so I got to change that. So chairs, if there are 30 chairs in a row, how many tables will that be? So again, that's it, working backwards. That we have C is 30 plus 2. We want to remove that 2 from both sides, so we have 28 equals 3n. Divide by 3, divide by 3. 28 divided by 3 is 9. So 9 tables, and let's just see what that actually gives us, because it's 9.333, sorry. So 9 1/3. So that's not going to give us enough. So 27 plus 2, that's going to give us 29. And that will be enough for some classes, and this is where it comes into the logic of the problem. So maybe some rows do have 9 tables, and other rows have 10 tables, so that we can get that. And you would show me that calculation piece, that some rows would have to have extra chairs, and some rows could have less chairs, because not all classes have 26 to 30 students. So then you would need to finish asking that question. I'm just pulling it up here. Sorry, I've lost the question. So you would need to finish answering that question of how many rows or how many classes are in the school, how many rows would we need, and then how many desks or tables would we need to satisfy however many classes. So our school, let's say there's 10 classes per grade, we have 30 classes, we would need 30 rows, and you would need to justify how many rows of 9 and how many rows of 10.